No, I was definitely recording. And we're back. Sorry, virtual students, you'll get 2 videos. So our goal in these, when it says solve each question or solving for x, our goal in these is to make each set of parentheses equal to 0. So -6 and 5. Why don't you go ahead and try each one of those types of problems on your own?
Are you going to need these to be able to do the homework?
I think we're going to go over these together right now. But I need to see that you have them down. So I guess, yes. Yes, Michael. You need to see them.
Okay. But I just want to say it's just 0, but I don't know if it's wrong.
Give these a try.
I'm a wee bit lost. Just a wee bit.
You're not European.
Huh?
You're not European.
I'm a lot. I'm from the Aztecs.
From the Aztecs. It probably is that simple as what you think.
We'll go about 30 more seconds.
Dow Jones is up. Holy.
Alright, so if we're looking at the first one, we need to know what we could put in for x out in front to make that whole thing 0, and also what we could put in for x inside the parentheses to make this 0. So, what could I put out for the x out in front and make this whole thing 0? We multiply it and make it all 0. 0. Yep, we put 0 in for x. We'll have 0 out in front. 0 times anything will give us 0. What about our x inside the parentheses? 1. 1 minus 1 gives us 0. So it doesn't matter what's out in front. We're going to get 0 no matter what. Look at number 3. We put positive 4 in. 4 minus 4 is 0. And positive 6.
Oh, A plus.
Good job. Now, look at.
Wait, why didn't you have to 0 with it?
Where's Goosegraph? Is it easy graph or is that what it's called? No.
It's good.
It's definitely. Did they take it away from it? Where is it? I'm not thinking. We just find graph.
There's no equities.
Alright, so we have this idea when we see these x's and things, and they're equal to 0, we can figure out what our x values need to be to make the whole thing 0. Here's where this fits in big picture. Let's see, x. here's where this fits in big picture. If we think about, I don't have everyone's attention. Look up at the board. If we think about graphing the things, now I know we haven't graphed these at all yet, but when we graph these binomials, then they look like a parabola, which maybe we haven't seen very much of, but they're a loopy graph. And what we're finding when we find these x values is we find where the graph crosses the x-axis. So this was the first one that you guys just looked at. So x times x minus 1, our answers were 0, right over there, and positive 1. Funny how that works. So these x values that we're finding are the x-intercepts. So far we've only focused on the y-intercepts when we do point slope. No slope-intercept form. But now when we're finding these x's, we're finding the x-intercepts. So what was the other one we looked at? It was, so we'll just go x minus 4 times what? X minus 6. Now look, x minus 4, x minus 6. Our x-intercepts are 4 and 6, just like our answers were. So, theoretically, if you had no idea what those answers were supposed to be, was z equal to 0, you could graph it, but it might be easier just to look at it. But that's big picture where we're heading eventually, where you will definitely head in algebra 2. Did I stop recording? Oh, we're still recording. Questions on those? Now, one term that you will see, one new vocab term that you will see that we need to talk about, is that these two values, we call these the roots, or the roots. What is it, roots or roots?
Roots.
I say roots.
With the Kinton?
I'm saying roots. What?
We never got to finish roots. Mr. Schoon would let us watch it, and then we never got to finish it.
Oh, sorry. But these x values that we find, we're finding the roots of x times x minus 1. So that's a term you'll see. All right, one more example, and then you have practice, and then you have worksheet. So we should get out of here. No homework today.
Great. Also, we do that.
What? No, we did that yesterday. Should happen. All right, so here's a real-life example. The arch of a fireplace can be molded by y equals -1 times x plus 18 times x minus 18. So let's just say that's the graph that you could use to mold this arch in the fireplace. If you can't see it too well,
And get better eyes.
then get better eyes. Yeah.
I have glasses and I can see this.
It's this arch right here. So it's saying, just like we looked at, here's the graph of the equation up there, where x and y are measured in inches. The x-axis represents the floor. Find the width of the arch at floor level. So they're saying this x-axis represents the floor, and they want to find the width. Why did not let me switch colors? The width of the fireplace. Who has an idea? How would we go about finding the width of this fireplace?
The width.
You need to find that red line. Remember,
Redliner.
this is our x-axis. Hey, there's a lot of side conversations. This is the last example we gotta look at, and then we'll get through it. We have our x-axis across the bottom. The white graph represents the equation up there. So based on what we've talked about, how could we find the length of that red line? You could count the squares.
1, 2, 3, 4, 5, 6.
Before I look at the picture.
our x and y axis right here. We want to find that red line, which goes across the x-axis. Remember, we just talked about those x values that we find represent where our line crosses the x-axis. If we look up at that y equals -1,9 and all that kind of stuff, what would our, if we wanted to find y equals 0, if we want to find the zeros, find the roots, what would they be? Some of us, right? -18 and 18. Right? We want to find the zeros. Now, -1,9 out front, but still 0 out. If we get what's going on in the parentheses, the 0. So remember, we talked about those x values represent where our graph crosses the x-axis. So that means right here, we'd be at -18. And here we'd be at +18. So if we wanted to find the length of this line, how can we find that? What would it be? What I just drew in the red is our fireplace and our graph. We want to find the length between -18 and +18. What would it be? Well, that would be the, if we add them together, it'd be 0. But what's the distance between these 2 points?
36.
36. Oh, I didn't hear you. Sorry. It'd be 36, right? Because even though this is at -18, we move 18 units this way, gets 0, move another 18 units. So the length, or let's say the width of that floor of the fireplace would be 36 inches. Don't worry, there's going to be one just like this on the counting the squares. I mean, it might work.
I don't think there's 36 squares.
Yeah, I don't think that's
There's not 36 squares. They're scaled, I think, each box represents 5 squares. But hopefully we see how we can find this. What questions do we have? Like today we're practicing examples that look just like these, and then 1 or 2 story problems that look like this. That's all right. All right. So yes, Lucian.
So with that, I'm good at for the first one, 2 and 8, and then on the second one I wrote -2, because then it would be 11 and -11.
I see where you're getting at. I like the way you're thinking. Not quite. Okay. We need to learn a new trick. I think this was supposed to be my second set of examples slide, and then I accidentally made it orange. It didn't have enough. Yeah. That's on me. Okay, here we go. We ready? This is part 2 of the lesson. This will take like 2 seconds. We gotta learn a new trick. And it has become known as the swoop, there it is trick. Alright? Swoop, there it is. Alright, I'm stealing that from Mrs. Stone, don't tell her. If we want to find what values P could equal in this first one, remember we need this first set, we need to see what number could go in for P and make this first set equal to 0. So we need to use the swoop, there it is trick. You ready? We need to take this 3. Really what we end up doing is we taking, hey, if we're not listening, we can't learn the trick. we need to take the number that is with our variable, so this 3, we need to swoop it under the 5. Whoa. And whoop, there it is. So our p-value, that would make that 0,
Hold up.
is negative 5/3.
You put it through. Oh.
Swoop, there it is. We gotta change it to a negative.
Is it
We gotta
negative
take-
5
yeah,
over
take
3 or
that.
negative 5 over 3?
Negative 5/3. So with the second one, we need a swoop. There it is. Positive 5/3.
You know, I guess this isn't that.
Swoop, there it is. But if we just look at that, let's say we look at the negative 5/3. We plug that in for p. Here's why it works. We take that negative 5/3 and plug it in for p just in that first set. 3 times negative 5 would give us negative 15. Negative 15 divided by 3 would give us negative 5. So negative 5 plus negative 5 gives us, and everybody said, negative 5 plus negative 5. 0.
Wait, negative.
Look, we could do, if we were solving within the parentheses, we would do 3 times negative 5 gives us negative 15. Divided by our 3 would give us negative 5. So then negative 5 plus 5 would give us 0. So that's why swoop there it is works. Now in the second one, we need to start here, swoop, there it is. So x would equal 2. Remember, we still need to take the opposite of that sign. So when we swoop, there it is, we need to make sure that if there's negative in the middle, we got to go positive. If there's positive, we got to switch it to negative. Now, with this number 6, are there going to be 2 answers for x? No, because if we write number 6 all the way out, it'd be 12 minus 6x times 12 minus 6x equals